Hello. This in my hands is of course Concorde, even if it is in Lego. It once soared the skies at 1,350 miles an hour, 2 times the speed of sound, inspiring those that raced across the North Atlantic with luxury, speed and engineering excellence. It dwarfed the 3,500-mile flight from New York to London to just a 3.5-hour skip over the pond, a flight that nowadays takes 7.5 hours. But did you know Concorde wasn't actually the first, nor the fastest, supersonic airliner, and that there was almost an American Boeing competitor? Concorde first flew commercially in 1976, but it was in the 1950s where the wheels for supersonic airliners first took off. The British began investigating, and through studies, testing and experiments, parts of the initial design began to come to life, from choosing a long, slender body to the choice of aluminium for the airframe, and even partnered tests with NASA helped sculpt the silhouette of the famous Delta wing. At the same time, French teams were also investigating and came up with their own independent but very similar idea. And so in the 1960s, a partnership began to form, with French teams and British teams working together to finalise an idea. And this culminated in 1962 signing of a treaty between the British government and the French government to finally develop a supersonic airliner, with Concorde's name deriving from the British and French words meaning harmony or treaty. And so, in 1965, the British Aerospace Corporation, now known as BAE, began constructing their prototype, the 001 in Bristol, and the French company now known as Airbus began constructing their prototype, the 002. Now, it was actually the French prototype, the 002, that first took to the skies in 1969 and was the first to be involved in supersonic testing. However, finally, in 1976, on the 21st of January, passengers for the first time ever were taken faster than the speed of sound, as British Airways and Air France both simultaneously carried passengers supersonic from London to New York and Paris to Rio. Despite this success, on the other side of the world, behind the Iron Curtain, a faster version had already flown. The Soviet-built Tu-144 had already flown supersonic 5 months before Concorde, had a top speed of Mach 2.15 compared to Concorde's 2.04, and was even a slightly larger plane. However, this does not necessarily mean it was more successful. Shadowed by the aftermath of a fatal 1973 Paris airshow crash, plagued by technical difficulties and facing similar economic and commercial issues that Concorde faced, but vastly exaggerated in a communist state, the Tu-144 only flew passengers for 3 years and carried mail for 8. Of 102 commercial flights, only 55 carried passengers. Also, on the other side of the pond, in the 1960s, the US and Boeing were also looking to make their own. Wanting to go bigger, better and more American, the US government invested $1 billion into the project, and they came up with the idea of the B-2707. However, perhaps this project was too big, and after spiralling costs and technical difficulties, President Nixon in 1971 officially canned the project. However, even though it was cancelled, the full-scale mock-up was still built, however it was never to be lifted off the ground. So, now you know about how Concorde came to be, and how the American one didn't, let's talk about some of the engineering of the Concorde. At a first glance, this certainly does not look like your average Ryanair or EasyJet commercial plane, and it has many features of exciting engineering, such as the droop nose, allowing pilots extra visibility during takeoff and landing, but still enabling an aerodynamic profile during flight, or the fact that this was the first airliner to use fly-by-wire system controls. However, what I want to talk about are the wings and the engines, the up and the forwards. Most passenger planes will probably not be carrying the space shuttle. However, more than likely, they will feature these kind of wings, the long, straight, swept wings. However, to be used at speeds on the Concorde, they would cause way too much drag, and so were not used, and the Concorde designers went for the much more uniquely shaped and uniquely named Delta swept overgall wings. Now, another reason these were chosen was because it's found on Delta wings, vortices would form along the top surface of the wing. And what these vortices would do would induce an area of low pressure on the top surface of the wing, increasing lift. Now this increase in lift was further strengthened by how far along the wing it acted. So Concorde's wing was stretched right along the fuselage. So as you can see, the unique silhouette of the Concorde wasn't just crucial for speed, but also helped increase performance at low speeds, enabling Concorde to take off, ensuring that it could land safely and smoothly. One of the most exciting pieces of engineering on the Concorde was, of course, the Olympus engines. Now, there are three main types of engines you'll find on aircraft. Turboprops, very efficient with a propeller at the front, but not built for high speeds. Turbofans, again, very efficient, but at the time were found they had a frontal area that was too big and would cause too much drag to be used on Concorde. And finally, what Concorde uses, turbojets. 4 Olympus 593 turbojets to be exact. Now, each of these monsters was over 4 meters long and 1 meter wide in diameter and could produce around 170 kilonewtons of thrust, and to this day remain one of the most efficient turbojets ever built. But how do they work, you ask? Well, there are 4 main stages of a jet engine: suck, squeeze, bang, and blow. Air is sucked into the intake at the front of the engine. Then it's compressed and squeezed in the compressor stage. Then it's mixed with fuel and ignited in the combustion stage. This causes the very hot air and fuel mixture to rapidly expand and be blown out of the exhaust. And it is the mass of accelerated air and fuel that results in thrust, propelling the Concorde forward. But there is one very exciting stage that the Concorde's Olympus engines also used, a stage reserved usually only for fighter jets, a reheat or afterburn stage, informally known as the spit stage. Additional fuel is spat and mixed into the exhaust gases and then ignited, acting like an additional combustion stage. And this produces significant amounts of thrust and was used during takeoff and to propel Concorde from subsonic to 2 times the speed of sound at supercruise. Now you know how Concorde came to be and how it flew. But what about now? As everyone knows, Concorde no longer flies in the skies. After the tragic crash in 2000, economic and commercial issues, as well as flight restrictions imposed by the tremendously loud sonic boom, Concorde retired from service on the 24th of October 2003. But there are plans to bring back supersonic passenger travel, with companies building on the legacy left by Concorde. NASA and Lockheed Martin have been investigating the X-59 on how to reduce the sound of sonic booms. Hermeus have announced plans for a hypersonic passenger plane called Halcon, travelling over 5 times the speed of sound, and has been linked to future Air Force One plans. Whilst it's still yet to be built, they have seen great progress and even successfully developed a turbojet ramjet hybrid engine, and seen further success with their uncrewed prototype Quarter Horse. However, most promising and most exciting is Boom Supersonic, who have already demonstrated with the XB-1 that by refracting sound waves in the atmosphere, you can achieve supersonic flight without an audible supersonic boom, a major milestone in supersonic passenger travel. Now, their plane, Overture, will cruise at Mach 1.7 and carry around 70 passengers, and it already has 130 pre-orders from American Airlines, Delta, and Japan Airlines. So, it seems that in the not too distant future, as passengers, we once again will be able to go supersonic. Thank you for watching.